In this video we'll show you how we can extract some shapes from an IGES file to go into the wire EDM system. So I've started the PM3D, the IGES import facility. So what we'll do is we'll choose this option, which is export the selected faces. So I'm only interested in the top face, so I click. That's identified the face, and to accept that I press enter. So then the format that we want to output is going to go to the wire EDM system, and we can set up our origin here. So these are the positions from the model. So I'll say the origin is the bottom left hand corner. So that's going to create an EDM program for me. So that's doing that now, and it's linking through to the EDM software. So what we've now got is we've got all those shapes come through into the EDM software. Now what we need to do is to create a two-axis profile for each one of those shapes, or as many of the shapes as we need. It could be that some of those shapes have been pre-drilled. So let's concentrate on the more awkward shapes, which is the ellipse and the large rectangle there. So one of the things that we need to do is to identify the spans which go to make up those elements. A span is a line or an arc segment. So with the cursor in the drawing area, if I right click the mouse, I can say number the spans. Okay, so if I zoom in onto this ellipse, you can see here that that ellipse is made up of quite a few spans. In fact, I think there's about 90 there. Now, one of the things that you don't know when you come in from the PM3D module is you don't know where the start point of the contour is. Now, you can find that out just by zooming in and finding where span number 1 is, which is just here. Now, that may or may not be a good position to start the wire. So what I'll do is I'll show you how we can select the start point. So we go up to the top menu, we go to contour, and we choose start point. So first of all, the help at the bottom says click to select the contour, so I click to select the contour that I want, and now you can see as I move the mouse around, it's locking on to the end point of any one of those spans. So if I choose the span, it probably doesn't matter too much which one I choose. So if I choose that one, okay, so what that does is it recalculates the contour and makes that span number 1. Okay, so now that we've set the start point, we need to create a machining command. So to do that, from the toolbar here, we choose two-axis job, and we can also do a full 4-axis, but for this example it's just be 2-axis. So we choose the contour that we want to machine, it's that one. Offset to the right, and we'll give this a distance in Z just for the graphics. So that will just create a machining program, but we've got other options that we can use. Under the options tab here, we can specify a pilot hole position. So this is where we're going to start the wire and cut the wire. So if we have a position on the screen, we can choose it, otherwise we can just type in a distance. The lead in and lead out can be set to linear, linear plus arc, or rectangular plus arc. So you choose the one that you want and then type in the values. The approach move can have its own generator settings. So if you want to use that, you check that box and enter the number of the generator settings for the approach move. If you wanted multiple cuts, then you can set up a rough cut, a middle cut, and a finish cut. If you need more than 3 cuts, then you can simply cut and paste this go round command and create as many cuts as you like. If you need to tag the part, then you can do by using this command and using a linear length. Your other options you've got is things like UV scale and rotate, repeat, and mirror. But the other thing under the options tab is that if you want this to be a job that has taper cutting, then you can set the taper angle in here. We'll leave those as 0 for the time being. Okay, so what that does is it creates a machining program for that one cavity. So now we'll move on to the other cavities. So let's assume I'm just using the center mouse wheel to zoom in and out and pan as well. So if we look at this one here, for instance, we've noticed that that's got 4 spans on it. So if I want to choose a start point, I go to Contour, Start Point, identify the contour, and notice how the cursor changes. But now if I right click the mouse, I can choose a position. So if I say near the line or arc midpoint, then click, then what that does is it splits that bottom line into 2 segments. So I've now got 5 elements that go to make up that rectangular shape, and I can use that as the start point for my go round command. So again, I use 2-axis job, choose the contour I want to machine, set the offset to the right, set the Z distance to 20, and in this time I'll have a lead in, a lead out. Sorry, let me do my options first, and set my pilot hole to say 5mm, I guess, and then the lead in, lead out will be a linear plus arc, and I'll have a 2mm radius. Okay, so that gives me a linear move, an arc approach, goes around the contour, and then an arc runoff back to the start point. And I can do exactly the same thing with the rest of those contours. If I look at the geometry in the ISO view, so what that does is it starts off at the datum position, moves to the first contour, rapid, stops, allows you to thread the wire, machines the contour, and then goes back to that start point, cuts the wire, rapids across to the next position, stops, threads the wire, machines around, stops, cut the wire, and then rapid back to the datum position. At any time we can run the simulator. So that's loading the simulator now. We don't need to do anything with these options, we just click the simulate button, and then that loads the machine tool simulator. Here we can show the material as solid or as transparent, and then we have simple video controls at the top with a slider for speed here. So if we just run that, and at any time we can now on this graphics you might see a couple of odd colours because of the fact that this is being recorded. At any time, if we want to, we can make the upper and lower wire guides transparent, or we can switch them off completely to make the graphics clearer. Okay, so we'll come out of the simulator, back into here, and then the last thing would be to post-process that. So then it's just a question of choosing the right post-processor for your particular machine tool, and then it opens up a window at the bottom here which has got the G-codes for that program. If you want to send that directly through, if we have an RS-232 link, then we can do that from here, send NC program to, and then we choose the configuration file to match the machine tool controller, get the machine ready to receive, and then send the data through. Okay, so that's how you do it.